is kind of a pain in the butt way to look at things. Because it's very handy, but going on further, doing 360 degrees is fine. But when we get to 900, as we get to 900 and bigger degrees, it becomes harder and harder to do on a circle. So I want you to imagine that what we're doing for the next week, this is for the next week, is that we are taking this dude right here, and I am turning him into Pac-Man. So here he is. Here's Pac-Man. Y'all see him, right? And I'm going to make him a little bit of a mean Pac-Man because it'll show it better on the graph. He's got little fangs on the bottom. So what I am going to be doing, what you are going to be doing in essence, is we are taking Pac-Man and we are going to be cracking him open, and we are going to be putting his head, his top part of his little head, right here, and then we're going to put the bottom part of it right here, and that we could keep on going with little Pac-Man over and over. That's literally what we're doing, and I'm going to show you it mathematically right now. I'm going to show you what it looks like. So if you see this, this is what we're doing. We're taking these points right here, and look how these are all positive. They're on the top part of our graph. They go right here, and then we're taking these points down there, and we're putting them at the bottom. Does that make sense? Now, here's what's interesting. We can keep going around the circle over and over, so our wave can keep on going forever and ever. I just keep going around the circle more and more. So today we're going to learn how to do this. Yes. So here's what today is: our last day ever being forced. If you go on to college, you're on your own. But this is the last time you will ever be forced in secondary school to do a T-chart. We're going to do 2 today and never again. Never again. And for a lot of you, you will never literally do another T-chart as long as you live. If you're going to college and you're taking stats, you do not need to make a T-chart. So here you go. Yay for you. Last time ever and ever. Are you ready? Let's do this. So the first thing that we need to do is we need to know we're going to be doing X, and we're going to do the sine of X, right? We're going to make this T-chart, and in the beginning, it's going to look scary. But then at the end, after we do it 2 times, you're going to be like, oh, wait. And then after that, you're not going to need to do it anymore. So our goal is to crack poor Pac-Man open and take all of this junk and put it over there. But I am way too lazy to do that. And here's why I'm way too lazy. That is a terrifying number, root 2 over 2. Who the hell even knows what that is? I don't even know what that is. And negative root 2 over 2. I don't even know what that actually is as a number. So first thing I'm going to tell you is this. So as long as you're not talking over me. Okay. So here's what we're going to do. We're going to stick with stuff that we like. And the first thing that we're going to do is we're going to notice that there are going to be some numbers on this whole thing that we like. So we're going to deal with those guys, right? We're going to deal with those guys. And you can just watch this. Now, the next thing that we need to know is we need to put our numbers on our x-axis. And if you had Tobin last year, you did this with degrees. You started on this guy down here, and you put like 0 degrees, 90 degrees, 180 degrees, and you went like that, right? That's awesome. But we're in pre-calc now, and we're not going to use degrees for 2 reasons. One reason is, like I said, they're kind of fake. They're just some random dude back in ancient days who thought 360 was a magical number. So 360 is not really magical. 2, they are what's called a relative number, meaning it's 1 degree out of 360. It's not a real number. So we, hello, pre-calc, are going to be using radians. So we're going to put this in radians. But I'm going to tell you something. You're not going to, I look at my eye just got eaten up there. You're not going to mind it. It's going to be okay. There's a weird thing happening, and let's see if I can get rid of it. I think I have 2 going on, and that's why it gets all sketchy. Okay, so the first thing that we need to do is we need to pick all of the radians we want for the not scary numbers. I don't want these scary numbers. They're too scary for me. So I am just going to use this guy and this guy. So the first radian I'm going to put on there is 0. That makes sense. I like 0. The next one that I'm going to put on there is pi over 2. And I want you to write it as 1 pi over 2 right now, and you're going to see why in a minute. Then we're going to come over here and use this dude, 1 pi. And then we're going to come over here and we're going to use this dude right here, 3 pi over 2. And we're going to keep on going, because if we got all the way back to where we started from, we know that's 2 pi. So on your little T-chart, can you write 2 pi? Now, to do a good unit circle graph, you need to do 2 revolutions. You need to at least go around your circle 2 times. So we need some more points on here. So I want you to see if you can see a pattern here. Now, the first thing I want you to notice is we alternate between a whole number, 0 pi, 1 pi, 2 pi, and a little fraction, 1/2, 3/2, and then there's going to be another little fraction. So I'm going to tell you what the next little fraction is, and I want to see if you can see the pattern. 1/2, 3/2, 5/2. So now we went whole number 1, whole number 2, whole number 3. Perfect. Okay, now, so Karen, now I'm going to really test you.
Oh, yeah.
1 over 2, 3 over 2, 5 over 2. You are fire. 7 over 2.
Oh, shut up.
She knew that though. Does everyone see that? Is everybody cool? And then if I want to do another one, what's right here? 3, then 4 pi. And if I want to throw one more on just for the hell of it, 9 pi over 2. It absolutely is. So could you do me a favor? Could you write them down here for me, please? Make a nice little chart like this and write your X values down. You're going to write these down so many times in the next 3 days that you're going to get really good at them. Some kids do it like this. They leave a space and they do the little pattern. 1, 3, 5. Does that make sense? And then they go back through and do the other numbers. To be honest, that's kind of how I do it. And then I go back and I go 1 pi, 2 pi, 3 pi, 4 pi. Does that make sense? Everybody cool with that? Now, here's what. We could also go backwards if we wanted to. Our circle could go backwards and we could have negative pi over 2. This baby goes on forever. That we were already saying this would be 5 pi if I wanted to. And then it would be 11 pi over 2. Do I need to do that? No. But it could go on forever. I need you to know it goes on forever. You just keep going around. Now we need to put some points with them, right? So now we're going to go back to our unit circle. And we're going to be using sine. Sine is the second guy. It's this dude right there. So 0 matches with 0. Pi over 2 matches with 1. Pi matches with 0 again. And 3 pi over 2 matches with -1. And 2 pi matches with 0 again. So watch the pattern. I start at 0. I went up 1. I went back to the middle. I went down 1. I went back to the middle. I went up 1. I go back to the middle. I go down 1. I go back to the middle. I go up 1. Okay, let's put these on our graph. Nice and easy. Here's a hint. When you're putting these on, say the back to the middle part. We have a tendency to go -1, +1, -1. It's 0, 1, 0, -1. It's got a middle jump there. So are you ready? Let's graph this baby. We start at 0. We went up 1, back to the middle, down 1, back to the middle, up 1, back to the middle, down 1, back to the middle, up 1, back to the middle, down 1. Hey, guess what? It's time to graph. You are not 5th grade boys. This does not look like a weird, I'm having a heart attack EKG like this. It's a wave. It's a wave. It's gentle. It's beautiful. If you need to make the noises, like I do when I graph it, do it. It's more fun. But it's like a roller coaster. It's smooth. You're not getting your neck all messed up. So are you ready? Let's start. I'm gonna do a nice and smooth. Couple things. Do not end it at that last dot. This is not a graph that ends. It goes on forever. It also keeps going down here. Put arrows on them. This is not a static graph. It's a continuous function. This is a function. It's beautiful. She's a function. We love her. That's the function of sine. You just graph sine. So we're going to put a couple things that are important, and you're going to write this on your paper, and then you're going to turn your paper over. We're going to do cosine, and then we're going to wrap it up. First thing that we need to know is the domain and range of her. I'm going to write it right here. Domain. Domain says side to side. What's fair game? And you know what's fair game side to side? Everything. All real numbers. I can go on forever this way. And go on forever this way. But range is important. Range has a very, very specific interval. Ooh, look at me using math words here. I can only go up so many and down so many. I would like you to see if you can write this in interval notation. It's going to have a -1 and a 1, and you want to think about what are the boundaries to it. Do I actually touch 1? Do I actually touch -1?
If it is two sides.
Say that again? Are we good? Okay. So now what we're going to do, we're going to do the same thing. We're going to go a little faster because now we got the hang of it. We're going to do cosine. So sine and cosine are two basic parent graphs. And then tomorrow and a little bit today, we're going to start messing with them. So here we go. Are you ready? Cosine. Turn your paper over. Make me a T-chart. Make me a nice long graph. And let's rock and roll. It starts at 1. Very nice. That's the whole difference. Look at you, remembering from last week. Would you ever skydive?
Yeah, I actually want to.
I was thinking about that the other day. I think I might, because here's what I don't like.
I think she's sweet.
I think I could do.
We can go from
I'm close. But here's what I don't like the feeling of falling. I don't like that. But I've heard it doesn't feel that way when you're, no, because the wind, they say it feels like putting your arm outside your car, or if you put because it's just a wind. So you're going at the same rate of the plane in the beginning. But I think what they do when you do it tandem, they tell you to count down with them, and then you just step.
So we do it with someone else. Like I don't think so.
You know you have to train. You have to train.
Oh, like you have to go with someone else?
Yeah, at the beginning you have to tandem turn. So that's the guys behind you, and then they do the whole parachute.
Yeah.
I kind of think I want to try.
I want to do it.
Are we ready? Here we go. So guess what? We're going to go a little faster. I got my spots on, but I got my girl Lyndon right here who said, hey, wait a second. She didn't say, hey, wait a second. I added that. She said cosine starts at 1, and then it does the whole thing. We go up, middle, 0, down, middle, up. But cosine starts at 1. So here we go. 1. And if you want to look on here, look, then we're at 0. Then we're at -1, 0, 1, 0, -1, 0, 1. I forgot that over 2, sorry. I do. Can you graph him for me, please? Does he look almost the same? Yeah, he's just shifted over a little bit. These graphs are called sinusoidal graphs, and they are wave graphs. Their sound waves are sinusoidal. A healthy EKG is sinusoidal.
Excuse me?
A graph that goes like a wave. Pi over 2, pi, 3 pi over 2. I have to always think about that one. 2 pi. No, some of this I just do in my head. It's been 30 years, for God's sake, if I can't do it now. If I don't know it now.
Yeah, probably. See, remember when you got mad at me for talking?
Shut up.
I was telling you to be quiet to listen to.
I love that. I love that. Are you ready? Don't start at 0. Cosine starts at 1. Here we go. 1, 0, -1. Please, if you do nothing else, do that top, middle, bottom, middle. Like, say it in your head. This is where we mess up. Even me, I have a tendency to be like, oh, -1 up to +1, and that's going to mess you up. You have a middle jump there. So think to yourself, you got to stop at the middle, right? Because what I'll have kids do is like, how can I have too many numbers left over? And it's like, because you forgot those middle ones. Is it wrong if you do it like this and you make solid dots at the end? It is. This graph doesn't end there. So please make sure you're showing me where he's continuing to go. He is continuous. He's not stopping. He's a function. Let's do his domain and range. Almost the same. Domain, all real numbers. We can go side to side. Range, we love the range on him. We can go way low or way high. Well, just a little way. Finally, the thing that's most important for you all, what's the difference between sine and cosine? Sine starts at 0. Cosine starts at 1. Okay, we got one last thing to talk about, and I'm gonna have a weird introduction, but I really like my weird introduction. So listen and don't interrupt me because I really like it. So I'm gonna say a sentence. I'm gonna see if anyone knows what I'm talking about. The Mavericks season just ended at the end of March. Does anyone? And I'm gonna tell you it's not about basketball. Anyone know what I'm talking about when I say the Maverick? And I'm going to tell you a little bit more. The Mavericks season just ended at the end of March. If you want to send in a video of your performance for the season, you have to do it now. Any guesses what I'm talking about?
What's going on? She's talking about how the
Mavericks is the only big wave surf spot in all of the continental United States. I'm talking about surfing. Because Mavericks is the most dangerous surf spot in the Western Hemisphere. The waves this year, the Mavericks season, runs from November to March. I've always wanted to go watch it. It's very hard to watch because you can't really see it from the shore. They had waves that they think are going to be measured out at about 80 feet. So I want you to imagine, I think this floor, the ceiling here is a 16-foot ceiling. So imagine what 80 feet would look like. It would be 5 of these buildings on top of each other. It's that wall of water, and you're surfing on it. And on Mavericks, the reason it works that way is it's a channel near Half Moon Bay that ends in rocks. If you wipe out, there's a good chance that you might die. So the reason I'm talking about Mavericks is because you send in a videotape of your performance, and it must include you surfing and videotape of flat water at the same time, because that's how they measure wave amplitude. You're writing this word down. We are going to do amplitude in here. And in Mavericks, they don't measure the top of the wave to the trough because water gets sucked out in a wave. They measure it top of the wave to flat water. That's how they measure it. We are doing the same thing. The amplitude of this little graph was 1. That's how big our little baby waves were. They took flat water and they went to 1. The amplitude was 1. I'm going to ask you guys to do this graph right now. I would like you to graph sine of x with an amplitude of 4, meaning everything stays the same, but now instead of doing baby waves that hit at 1 foot, these waves hit at 4 feet. Does that make sense? And amplitude is found in front. Yes. -4. Does that make sense? Great question. So we're going to do this one really quickly. We're going to go ahead and we're going to, the longest part of this whole process is putting these stupid things on. I'm not going to lie. That's the worst part. And when you get good at it, it goes really fast. But everything else after that, super, super easy. Because watch what happens now. Sine starts at flat water. Is everybody cool with that? So sine graph is right here at flat water. But the waves are pretty good today. Well, not great, but pretty good. That we're going to go all the way up to 4. Back to flat water. Down to 4. Back to flat water. Back up to 4. Down to flat water. Back down to -4. Back to flat water. And the difference between a amplitude 4 graph and an amplitude 1 is just, it's a little gentler. How did I know the other one was 1? Because the number in the front was a 1, but you couldn't even see it because we don't always have to write the 1. That's what a 4 looks like. Yes.
There's only this room of 16 feet, right?
I think it is. What do you think it is?
No, so it's not. I was like,
Stand up. No.
So it's 2 of Noah's. No.
Oh, I think it's 14 feet maybe.
No, it's like.
I think it's 4 feet above your head.
It's like 12.
If you can touch it, it's definitely below that.
Okay, so that makes the wave even, I'll be honest, that just makes my point worse. That 80 feet is crazy high. Yeah. Okay. So I'm gonna wrap up.
There's no arrows on this?
Oh, sorry. I would like you on your desk. This is your homework. You're gonna do it right now.
Yeah.
What happens on this one? The amplitude is 2. Gentlemen. The amplitude is 2, but on this case, we're not starting at 2. We're starting at -2. Does that make sense? So we're going to start down. You're like at the Big Dipper at Southeast. You're going to come out of that tunnel, right? You're starting at -2. Okay, on your desk, on your paper, it's up to you. Okay, but remember cosine starts. not a zero. So cosine would start here. And then, does that make sense? Cosine starts on the number. It doesn't start in the middle. So normally cosine starts at 1, but because my amplitude is 2, it would start at 2, and then I flipped it, right? I am now starting at -2. You're thinking you're like -2, middle, +2, middle, -2, positive, middle, positive. Very nice, very nice. You guys, do you take a picture? Oh, you can. Because that's impressive. Like that looks like some crazy stuff, right? That looks like some really crazy stuff. You guys are great. It is the it's easy. Nice, nice. That's it for me for this one. I think we're done. Yay. Bye everybody. Bye people at home.